Hello and welcome to this talk on AppSec exploits, evidence manipulation from custom code flaws. I'm excited to talk about how AppSec relates to data forensics and incident response. Now, my background is primarily in AppSec, specifically, not in data forensics, but because of my focus on AppSec, I'm really excited to share about my perspective and how that can impact some of the work that you all are doing, some of the work in the DFIR community. So I want to start this talk by asking a question. What's the fastest way to the center of a modern network? So when I think about the traditional way to get into a network, you might think about port scanning and banner grabbing and looking at the attack surface. But a modern network is more often than not something like this. It's maybe an AWS VPC. You have your load balancers, and you maybe have some auto scaling groups set up in there for your applications, but you may have a database that's connected to this application. And the fastest way into this VPC that has all these systems connected to it is a simple web request over HTTP. And all of a sudden you have some of your own crafted HTTP inside, in this case, is a WordPress instance in this architecture. And if you can exploit some custom code flaw within this application, it may not even be published. There may not even be a known CVE for this issue. Then you can get access to maybe some data or a system, or leverage the access of this VPC of this network to gain more access. So an attacker can really leverage just simply a web entry point into these networks. And so this is certainly a big deal. So I think talking about AppSec within the space of looking at an attacker and incidents is going to be very important. What this looks like, the first item here that I'm seeing is that there's a trend for cloud infrastructure being hardened very well. I mean, you're not going to hear about any of the big cloud companies where there's all these exploits against their infrastructure. They've really hardened this, and they take their job seriously, of course, to have the security that is in their control be done well. And then there's, of course, all the applications that are running on top of that, which is another story. Now, there's also configurations where the users of these cloud networks could misconfigure. You maybe hear about an S3 bucket that was misconfigured and all this data is leaked out. Well, there's configuration monitoring and scanning tools that are constantly being improved upon, and maybe new ones being released, where these configuration issues in the cloud are going to happen less and less, hopefully. And what that leaves us with is custom applications with unique logic flaws that are running in these modern networks, and these are still going to be a good entry point into these networks. So I think that's why, again, AppSec is really important, and it will continue to be important going into the future, and understanding how these custom logic flaws can impact an investigation, and how it can make things a little weird when you're looking through the logs or some of the application data. It's going to be really helpful to understand this AppSec perspective. So a little bit about me. My name is Jeremy Polansky, and I've been in cybersecurity for the better part of a decade, not specifically in DFIR. I'm currently the director of DevSecOps at CalVista Software, and we help companies develop software from startups to enterprise, everywhere in between. I have a history of being an AppSec consultant, a security architect for application security, and even a vulnerability management tool helping with that in the AppSec space. Now, when I was getting into security, I did look into many different areas. Of course, to be in security, you have to know a lot of different technologies. And so at one point, I built a forensics lab for a summer camp that was geared towards high school students, where they image a flash drive and look through image of a hard drive. And so I do have some knowledge about forensics, but I sort of veered away from that into my professional career. So I understand a little bit about maybe some of the context that you're looking at this from, and hopefully I can speak to that. But really, I want to give my perspective on what AppSec is, and whenever there's a need for you to understand AppSec in a job or an investigation. Hopefully this information can be helpful. So the goals of this talk: 1, I want to explain application security, or what I'll call AppSec, versus what's maybe a traditional network security or information security perspective. And of course, AppSec and network security, it's all security, but AppSec runs really deep, and so it's a bit of a different niche. And I want to explain and highlight the differences of just looking at AppSec. I want to also highlight the importance of having expertise in AppSec when looking at an investigation where there's custom logic that was exploited based on what appears that the attacker did during the attack. Also, I want to give some exploit examples of what this can look like, especially when it can manipulate the logs or certain locations or sources of the web requests, where it can be a little bit confusing what actually happened, and how do you build a timeline when logs are manipulated? How do you understand the application, and if the application could have allowed for this manipulation? And then I want to include a few resources for further learning, for reference, even down to understanding where to look to learn how these exploits happen and how to test for these things in an application. So a quick case study. So a number of years back, there was a CapitalOne breach. Probably most of you have heard of this one. I want to talk a little bit about the timeline of what happened here. So there was an insider threat, and there was an exploit against various systems, and including an application vulnerability. So first, the unauthorized access happened. It got through a web application firewall. There was a misconfiguration there. Then there was a lack of logging, and so the exploit wasn't detected right away. And then ultimately, there was a server-side request forgery as part of the exploit to get the data. And so it would be important when looking at this CapitalOne breach to understand, in this case, server-side request forgery and what happened there, to validate that the exploit happened, where it came from, and that there was a jump from one app server to another with this server-side request forgery exploit. This is one example, the server-side request forgery, that I'll go into a little bit more in a little bit. Before I get into that, I want to highlight what AppSec really is. I want to compare it to traditional network security and explain some of the concepts here. So AppSec, network security versus AppSec. So one, the tools are different. Traditionally, Nmap and Metasploit and Wireshark, these are tools that we all know. These are traditional security testing tools, visualization tools, exploit tools. In the AppSec space, if you're just looking at, I want to exploit over HTTP, over a web request, Burp Suite Professional is the #1 tool. And there are, of course, equivalent ones, similar, but essentially it's a proxy that allows you to do all the things that Nmap or Wireshark or Metasploit would do. Now it's all custom. So in Metasploit, you can exploit a certain CVE. Well, with Burp Suite, you can craft requests to exploit custom logic flaws in this application, because applications are always unique unless there's a certain version published and then released out into the wild. That would turn into a known CVE exploit. But Burp Suite helps to detect these even before that happens. So for exploit types, for traditional network security, there's a CVE, there's a known system. Maybe you're looking at banners and you can understand if these CVEs might exist. For AppSec, you're going to look for a CWE. This would be a common weakness enumeration, and I'll go into that a little bit more in a bit. But this would be a vulnerability class. This is going to be a unique payload for that specific app logic most of the time. And there are going to be some CVEs. Typically, it's going to be in the libraries, but that's going to be behind the scenes. You're not going to see a banner for which encoding library they're using, or which parsing library they're using to look at your XML. When you're conducting an AppSec assessment, for example, you're going to have to understand what could be possible and then test that out. So it's a bit of a different approach than the network security typically is. Now the tech stack is also different. And traditionally, you're going to have different servers and endpoints, maybe Active Directory that you're looking at as a big centerpiece for the network, maybe DNS that you're looking at, firewall that you're going through. When you're looking at just attacking a web server, you're going to understand the custom code and what could be going wrong with that website. You're going to have to understand the web languages and frameworks that could be in use there. So for example, if something is written in C, then there could be a higher chance of buffer overflow, and that could be an attack that you want to try or look out for. For third-party code libraries, you have to understand how those mesh in and how you can maybe exploit some of those known vulnerabilities in libraries that might be in use. And then there's a web application firewall at play normally here. And that's going to be like a deep packet inspection where it may even decrypt the data and look in all the details, the payload of all the attributes that are passed in to the application, and maybe even look for some bad characters there. But there's even some ways to get around a WAF. But the approach there is going to be different than like a traditional firewall where you're looking at IP addresses and networks. And then lastly, the network topology is what you maybe focus on when you're trying to get into a network and hop between different computers, different endpoints within the network. With AppSec, you're looking within that application to see if you can exploit it. And so you're going to be looking at data flows. You'll be looking at APIs that it's using. And again, it's focused in and really honed in on the application, which is why application security is very deep within just the app, just the HTTP requests. Network security, on the other hand, is much more broad. So it's not like AppSec is super complex and network security is basic. Network security is very broad. AppSec is much more limited, but it goes very deep into what it's looking at, which is the code. So oftentimes, if you want to really dive deep into AppSec, you have to understand the code. You sometimes have to be a developer to really get deep into AppSec, or at least know how to read code. So in general, AppSec, it's about snowflake vulnerabilities, where there's a certain type of vulnerability, and you have to really understand how to exploit that to see if it's exploitable. Versus network security, where it's much more of a binary. Do we have this version? Is there a firewall in place? Are we blocking this? Yes or no? So for some examples of this, let's go into the exploits. So there's a handful of exploits I'm going to show, but first I want to go over one more time the difference between a CVE and a CWE, especially for those who may not understand what a CWE is from experience. I want to explain just to make sure that we get this difference. So a CVE is a common vulnerability enumeration. So this is a known vulnerability. There's a system and a version where if you have that system and version, then you know that CVE could exist and could be exploited. There are oftentimes specific payloads that are associated with that CVE and is created from some weakness in the code. But because it's published, there's a known version, then it is turning into a CVE. It can be published as that. But if it's not published yet, then there is some weakness within that application, and that's what we call a CWE, a common weakness enumeration. And this is a category of a code flaw. So it's not necessarily released yet. It's not necessarily in a certain version, and it could look different. There could be different payloads. There could be different ways to actually exploit this because it's in this custom code. But if it is published, then it can become a CVE if it's found by a vulnerability researcher. So those are the difference between these two. A CVE is a known vulnerability. A CWE is just a class. It's a way of approaching a certain flaw within the code. So I'm going to cover 5 different vulnerabilities, CWEs, that you might find in custom code that could impact an investigation, specifically for logs, for looking at what happened within an exploit. So the first 2 I'm going to cover are request forgery attacks. The first one is SSRF. I mentioned that in the CapitalOne example. The second one is cross-site request forgery, or CSRF. These are both request forgery attacks, but they're a little bit different, and I'll explain each of those. The third one is HTTP request smuggling. This is actually an exploit against the HTTP protocol, and it allows the attacker to smuggle packets into the network. It's really interesting, but depending on where you're logging, the intermediate servers may not see that request, and they may not register it properly and put the proper checks in. So that could be very interesting for how an attacker can get into a network and understanding how they may have done that. The next one is CRLF injection, also known as log injection, simply put. This would, of course, be very annoying if there are fake logs within the logs that you're looking at for an investigation. And also, I'm just going to cover insufficient logging in general. There's some concepts around that I want to talk about. Of course, an application that isn't logging important data or specific data could make it very hard to really understand what happened there. So we're going to dive deep into each of these, and I'll explain what the vulnerability is, how it could impact an investigation, and hopefully it'll shine some light on ways to look for these types of exploits as you're looking at investigation. So the first one is SSRF and it's CWE 918. And I'm just highlighting that this is a type of vulnerability or a class of vulnerabilities. No need to memorize the CWE or anything, but we'll put a link to the MITRE page for CWE, so you can reference that if you're interested at the end. So for SSRF, this is server-side request forgery. Essentially, this exploit causes an app server to make a request on the attacker's behalf. So any permissions that the server itself has, for example, it's within a VPC, so it can maybe see all the other servers within that VPC. The attacker can cause the app server itself to make another request to some other system. And it could be an HTTP request, it could be FTP to try to exfiltrate some data, whatever that is. And the attacker can then leverage that. Now, this is a very important attack. It's actually part of the OWASP top 10 web app security risks. It's the OWASP top 10 list. And there's others on the list that are maybe classes of vulnerabilities like broken authentication. But I believe it's number 10 on the list right now is SSRF, just this single CWE. So it's a very important vulnerability. And there's been some pretty big, CapitalOne, for example, some pretty big breaches that server-side request forgery has been a part of. Now there's a URL here that I crafted that might be what a server-side request forgery payload might look like. So you have your example.com, and then one of the parameters here is a URL equals, and then there's another URL in here. Now the web app might look at this URL parameter and say, okay, the user wants me to make a request to 1.1.1.1/admin. Now, if the web app doesn't validate that the user has permission to access this other system, then it may use its own permission and say, okay, I'm going to try to access this, and it may succeed, which could be a problem. So that's the essence of this vulnerability. So the impact of this is that the threat actor can pivot by way of an application's own privilege. And then, of course, the path that this attack is going to take is going to go through an app server by way of these custom logic flaws, again, that may or may not be published. So it may not be known. So you really have to understand the code to see if this is possible. The second vulnerability is very similar. It's cross-site request forgery. And a CSRF or a CSRF attack tricks a victim into submitting a malicious request to the web server. And so this is a victim. It's not a web server, but it's actually another user, and it's their browser that makes this forged request. It's also known as session writing. So if I'm an attacker, I want to find a victim who has a session, maybe to their bank, for example, and I want to use that to have them make a request to their bank that benefits me. So a code example here would be maybe there's a tag, a link in a website, maybe view my pictures on social media, and the actual link is, you can see in that URL, it says bank.com, transfer, and there's an account name for Maria and an amount for 100,000. And so maybe this is my account that I want to steal some money into, and I want to take this from whatever victim. And so if they're logged in and they click on this link, then this link is then going to send this request to their bank. If their bank doesn't validate that this was a legitimate request or not, then it might use the existing session or the existing cookies in the victim's browser and validate this request. And of course, that would be a problem. Now, the impact of this would be that a threat actor can essentially use a scapegoat for their attack, which could be confusing because an attack could come from someone's computer, and that person may not even know that they were part of this exploit for the system. One of the big things too is this user may not have any indication on their computer that this happened. Let's say they shut their computer down and there's no history within the browser, so that way there's no way to identify the timeline of the attack just from the data in their computer. Now it gets even worse because CSRF is a bit of a complex vulnerability to exploit and to determine if it's exploitable within a system. So in this next slide, and don't study this whole thing, but I just want to give you the example. This is the decision tree for if a website is vulnerable to CSRF. You can see how many different questions you have to ask yourself if there is an exploit of CSRF in an application. It can get really complex, which means how do you determine if a website was vulnerable and maybe if it was vulnerable at a certain time? Now, some of these questions are if there are certain browser controls that the browser is enforcing, which could stop CSRF. So if an application is relying on some browser controls, then was the victim on that certain browser version at the time of exploit? And how do you determine these things? So the timeline can get really complex with all of these, little convoluted, tree here of is the application vulnerable? So what could happen here? So one of the things here is there could be, in theory, plausible deniability for someone who hacked a certain website. It could be something like, hey, you don't have proper CSRF controls in your website, and so I think that someone made me send that malicious request. And who are you to say that they're correct about that or wrong about that? Because if you can't prove that at the time of the exploit that there were proper CSRF controls, then can you really prove that the person who sent that wasn't tricked into sending it or didn't click on a phishing link that sent that malicious request? So browser controls constantly change. I mean, it seems like they can change every week even between all the different browsers and the different versions. And so it's really complicated to really track if the browser controls would have prevented that CSRF in the victim's context. Again, I mentioned the evidence is going to be on the victim's computer. And so attacker can either wipe the computer and claim that they were hacked, wipe their own computer, and there's no evidence of if they weren't the victim of a CSRF attack. Now also CWE 79, this is cross-site scripting. This is related and similar. You can also use these in tandem sometimes. So for example, an XSS attack can be executed on the victim's browser, and it could even be used to pull a non-secured CSRF token from the browser data. So there could be a CSRF token that's supposed to prevent CSRF attacks, but if it's not secured properly, then cross-site scripting could be used to get around that. And then the script can craft a request to, let's say, update the user's own email, and then the attacker can submit a password reset request to that new email. Now they've completely taken over an account. And so now they're going to get all that access that the victim has, whether that's to get into a certain system, to then get some important data, do whatever they need to do. So this could certainly be an interesting attack that can really use someone as a scapegoat. So the next exploit is HTTP request smuggling. And this is also known as HTTP smuggling or HTTP splitting. And this issue is where there are certain controls within the HTTP protocol and HTTP headers that allow an attacker to essentially smuggle an entire HTTP request into a network, and it can bypass certain controls, for example, authentication or authorization. So again, it's a protocol level attack. It can bypass auth in certain systems, but it depends on the way that packets travel into a network. So if there are multiple load balancers and proxy servers that are in tandem before you get to the web server, then HTTP smuggling could be possible in that system. So what it does is it can trick an intermediate server. There has to be a set of servers into sending the altered HTTP request to the downstream server. And if the downstream server then is trusting the upstream server for certain tasks like that auth, then there could be a bypass. So the impact here is that the applications may only log the non-smuggled packet, or they may only log the smuggled packet. And either way, you're going to lose context. So you're going to lose if there was a obvious HTTP smuggling attempt, because the HTTP packet was crafted in a way where there's obviously an attempt at this hack, or it could be the opposite way, where if you only log the application only logs where the packet is attempting this exploit, then you may not know if it was successful, and you may not know what was bypassed to make this happen. And then, of course, bypassing authentication is really important for any system. Now, to help to explain what this attack is, this is an image from Portswigger, and this is the company that makes Burp Suite. This is really the best visual that I see for request smuggling. And so there's these two servers, and the attacker sends this request. And you can see this post request here, where in blue, this is the typical request. There's a host header here in the HTTP packet. There's a content length and a transfer encoding header. Those are the two where you can change the values in there, and it can cause this attack to happen. But then there's this red. This is part of the body of the request. But because of the way the front-end server and the back-end server read the host header, the content length header and the transfer encoding header, the back-end server thinks that this is two different HTTP requests. And so now the first request is validated. The second request may completely bypass the auth that is on this front-end server here in yellow. And then that GET request to admin can be performed, and some state change can happen within the system. So depending on where logging is happening, maybe you get the logs from the front-end server, and there's no issues. Everything as far as authentication checks out. But really, there was another packet in there that was smuggled in. So if you don't know what this looks like, then you may not see that in the logs, and you may not see that it was actually accepted by the backend server and then therefore passed to the web application. The next issue here is CRLF injection or log injection. And CRLF stands for Carriage Return Line Feed. And what happens here is you can inject arbitrary logs into the system, and you do that by taking these carriage return line feed characters in some field, and the logging mechanism thinks that you're going to start a new line in the logs. So you can actually append log data into an input, a user input, and if the system doesn't look at that and treats it as unsanitized input, then there could be this issue. So of course the impact is going to be you're obfuscating potentially incriminating logs, whether it's just adding more noise so it's confusing to look for what's real, or it could even be adding logs that look legitimate within the system. That could really make it hard to determine which actions the web server really took. So an example, if you're going to frame incriminating logs, frame them by saying, I want to inject a log that looks like log out by user at 152. And then the user performs an attack at 153. But in the logs, it looked like they logged out because they injected that text that said that they logged themselves out when they really didn't. So an example of this, there's maybe what some logs look like. So the first one is the user log in, JSON87, and then they edit their email to JSON88@example.com. Then there's this user logout, and then afterwards there's a system crash of the payment service. But what could have happened is at 9:34 they injected this user logout item, and what that can look like is the actual payload that they gave the server is everything from the email onto the next line. And so if you look down there, the payload is their email, and then there's the /r/n, and that's the carriage return and the line feed characters. And so there's an example there of maybe the input field where they can input their email and then put the carriage return line feed and then whatever they want to inject into the log files. And if they understand the format of the log files, or if it's maybe like a typical system where maybe it's open source components where they can see what those logs are going to look like, then they'd be able to inject logs that look legitimate. So you have to know where to look to really understand if this is going to happen. Now, there are ways to mitigate this. You can encode output. So whenever you see any slashes, then you can encode them in whatever coding process you have there. And then in the logs, you're going to see a very odd line here where after the email, there's all this kind of junk at the end, and it makes it very obvious at that point. But of course, this is going to be, if this is happening within the system. If it is, then it's pretty obvious that someone was trying to do the CRLF injection. Last thing here, last vulnerability that we're going to be talking about is insufficient logging. Now, this is in general. Now, there's some specific examples of this that I want to show to really understand how this can occur within an application, not just the lack of logging in general, but logging specific types of information. So first of all, insufficient logging is defined as when a security critical event occurs, the software either does not record the event or omits important details about the event when it's logged. So obviously not recording an event is pretty trivial, but there's certain important details about the event that if they aren't in there, then it's going to be very difficult to really understand what happened and the implications of this log. So one instance of this could be idempotent message queues. So the term idempotent, I'm going to explain it in simple terms. Essentially, it's when making the request yields the same result. An example of this, we all have been maybe at a payment screen where it says don't hit the refresh button, because if it does, it's going to charge your card twice. That's because the app was not idempotent, because if you hit the same request, it's going to run that again. So an idempotent request, if you hit the refresh button on the payment screen, it's going to send the request. There's some extra context. Maybe there's a certain ID within that bill, and it's going to read that on the backend server and say, I already got this request for this payment. I'm not going to redo it. And so depending on if there's idempotence within an application, logs could mean different things. So in message queues, this is one really common architecture pattern within applications where there's a message queue that different parts of the system read. And sometimes if there's some outage or some issue, the different parts of the system could read these events multiple times. And if that is within the logs, then it's really confusing whether the server acted on these messages multiple times or just once. And sometimes it's dependent on how the application is looking at this data. So you have to understand, if idempotence is followed or not. And if it is, then multiple log entries may have not changed the functionality or the data in the system more than just that first time. So again, the impact is reviewing a message queue with duplicate entries may or may not have caused two actions by the web server. The determining factor here is how the app reads messages from the queue. If it has a check for if the second request is a duplicate or not. And it could mean that the developers have to add some additional field, some additional value. So that way duplicate requests, if it's really duplicate, it's going to have the same value in it between these requests, some ID. So here's an example of what this might look like. There is user login, and then there's these four edit account details for this user, and they log out. So what happened here? Well, it depends. If it's the same request that was sent multiple times, and there's idempotence within the application, then it may have only read the first one and ignored the last three. It could also be that there was some injection flaw within this edit account details action, and the user was using this to exploit a different part of the system. Well, we don't see the details of what they input into these fields within these logs. So we don't know anything about what they put here. And so it's really hard to understand if they were using this edit field to have some other attack against the system that could legitimately be part of the timeline for an attack. So to wrap up, for all of the impact on the evidence for all these different exploits, the source of requests could be impacted by different request forgery attacks, CSRF or SSRF. Also, the path of the HTTP packets could be impacted, where you may not understand where this packet came from, and you have to understand if the intermediate servers could have looked at this packet differently. That's specifically HTTP smuggling. And then logs in general. There's log injection, maybe log duplication, and understanding how the server is impacted by those duplicate logs, and if there's some data missing. So all of these could impact the evidence that you're looking at during an investigation. Now, there's some resources that I would call out to learn more about these specific exploits, or if you're in an investigation and you need to learn more about even a new exploit, and even just to reference. So the first one would be any OWASP tools for playbooks, exploits. The OWASP resource is really great. One call out here is the Web Security Testing Guide. There's a Web Security Testing Guide. There's an STG for mobile and other things. That's a very helpful playbook to look at specific CWEs, specific vulnerability classes, and understand how to look for those in an app, or even how to exploit those, like in an offensive security standpoint. There's also the MITRE CWE page. So just like the CVEs, MITRE posts CVEs and CWEs. So you can look there and reference those if you want to understand these different classes of vulnerabilities that could happen within this custom code. Now, there's also what's called a software bill of materials, and this is going to reference any of the components, and especially the software supply chain that goes into these custom applications. So there could be even known CVE vulnerabilities in these applications, and a software bill of materials is going to represent all the different components in this application. So if you want to understand application, you can ask the developers, hey, give me the software bill of materials. I want to know how many different external third-party code, open source libraries you use. CycloneDX is a way to structure these software bill of materials. They're doing some cool stuff around the different types of data that you can put into a bill of materials. And then Burp Suite, of course, it's from Burp Swigger, so you can look at Burp Suite. There's a community edition. You can play around with looking at a proxy, where you can proxy your own web browser to look at a certain website through that proxy, and then play around with repeating requests and fuzzing data and some cool stuff there. It's really helpful, and really I've had a lot of fun with Burp Suite within my career. So I appreciate it. Thanks so much. Hope this was really interesting. Now I know there's going to be a Q&A. If you aren't able to get a question in, reach out to me on LinkedIn. We'd be happy to connect, and happy to talk about AppSec.